Good day, Davao de Oro. Welcome to our episode of ratio-based instruction in general mathematics. Today's lesson, we are going to walk through Module 7 of your General Mathematics Quarter 2 with the topic Annuities. Again, this is Sir Jester E. Pescadero. Together with me is Sir Jeffrey T. Alfonso from Bantukan National High School Integrated Senior High School. Are you all set? Well, that's great. Now, let's start learning on air. This session helps you understand the key concepts of annuities and apply these concepts to solve real-life problems with precision and accuracy. And at the end of this learning session, you are expected to first, illustrate simple and general annuities. Second, distinguish between simple and general annuities. And third, compute the future value, present value, and periodic payment of simple annuity. To begin our discussion, let us determine first if there are concepts that you already know related to our discussion today. So let's have the pretest. Direction. Choose the letter of the correct answer and write on the sheet of paper. Number 1. It is a sequence of payment made at equal or fixed interval or period of time. Again, it is a sequence of payment made at equal or fixed interval or period of time. A. Future value of an annuity. B. Present value of an annuity. C. Annuity. Or D. Periodic payment. Number 2. It is an annuity where the payment interval is the same as the interest period. Again, it is an annuity where the payment interval is the same as the interest period. A. Simple annuity. B. General annuity. C. Annuity certain. Or D. Contingent annuity. Number 3. The time between the first payment interval and the last payment interval. Again, the time between the first payment interval and the last payment interval. A. Periodic payment. B. Term of an annuity. C. Future value of an annuity. Or D. Present value of an annuity. Number 4. The sum of the future values of all the payment to be made during the entire term of annuity. The sum of the future values of all the payment to be made during the entire term of an annuity. A. Annuity. B. Present value of an annuity. C. Future value of an annuity. Or D. Periodic payment. Number 5. The sum of all the present values of all the payment to be made during the entire term of the annuity. Again, the sum of all the present value of all the payment to be made during the entire term of an annuity. A. Periodic payment. B. Time of an annuity. C. Future value of an annuity. Or D. Present value of an annuity. Are you all done? Great! Now, let us check your answer and rationalize each of the correct answer. For number 1, It is a sequence of payment made at equal or fixed interval or period of time. The correct answer is annuity. As presented in the question, when we say annuity, it refers to the sequence of payment made at equal or fixed interval or period of time. How does annuity differ from interest, both simple and compound? Well, annuity may follow an interest pattern, but its payment is on interval basis. Number 2. It is an annuity where the payment interval is the same as the interest period. The correct answer is simple annuity. Annuity is classified according to the following. First is according to the payment interval and interest period. When we say simple annuity, it is an annuity where the payment interval is the same as the interest period. On the other hand, general annuity is an annuity where the payment interval is not the same as interest period. Meaning, in simple annuity, for example, if the interest is in quarterly basis, then its payment interval is in quarter also. Another classification of annuity is according to time of payment. We have ordinary annuity or the annuity immediate. This is a type of annuity in which the payments are made at the end of each payment interval. This classification of annuity is dependent on the time of payment. For example, if the payment interval is monthly, then every end of the month, the payment must be done. Another classification of annuity is according to its duration. We have annuity certain, an annuity in which payment begin and end at definite time. This classification of annuity is fixed. For example, if the due is at 2 years, this means that after 2 years, payment must be done. Number 3. The time between payment interval and the last payment interval. The correct answer is term of an annuity. Correct. There are terminologies of annuity and its presentation or representation. First is the term of an annuity, represented by small letter t. It refers to the time between the first payment interval and the last payment interval. Another is the regular or periodic payment, represented by capital letter R, the amount of each payment. Number 4. The sum of the future value of all the payment to be made during the entire term of annuity. The correct answer is future value of an annuity. This is another terminologies of annuity and represented by capital letter F. And for question number 5, the sum of all present value of all the payment to be made during the entire term of an annuity. The correct answer is the present value of an annuity and represented by capital letter P. In previous module, you learned about interest, both simple and compound. Annuity is somehow related to interest, but the main difference between the two is that interest can be collected through lump sum, while annuity is collected through time interval basis. Annuities may be illustrated using a time diagram. The time diagram for ordinary annuity, which means payment are made at the end of the year, is given as a line segment with an interval of periodic or regular payment on the upper part and number of terms on the lower part. The terms start from 0, then 1, 2 until n or t. For each term, there are equivalent regular payment capital letter R on it. Wants to know more? That's great! But before that, let's take a short break. And when we come back, let us discuss an example of calculation for annuities, specifically ordinary annuities. So don't go away. We'll be right back after some commercials.
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
And now we are back. Are you still there? That's great. Now, let us continue. We'll be going to solve problems involving annuities in two different ways. Take a look for this example number 1. Suppose Mrs. Manda would like to deposit 3,000 every month in a fund that gives 9% compounded monthly. How much is the amount of the future value of her savings after 6 months? To solve for the given problems, all we need to do is to take down notes all the givens. We have the periodic payment, that is capital letter R, and that is equal to 3,000. The term, which is represented by T, and that is equal to 6 months. The interest rate per annum, or the capital or the small letter I, and that is equal to 9% converted into decimal, that is 0.09. The number of conversion per year, represented by M, and that is equal to 12. Since it is compounded monthly and there are 12 months in a year. The interest rate per period, represented by J, and that is given by I over M. So that is equal to 0.09 over 12, and that gives us 0.0075. From the given of an example, we can say that to find the future value of the savings, all we need to do is to find the compounded amount of the savings per month, then sum it up. And that gives us, for the first month, remember that this month the payment was put on a fund, so therefore no interest has been applied, so that is equal to 3,000 also. For the second month, using compounded interest formula, we have 3 times 1 plus 0.0075 raised to the power of 1, and that is equal to 3,022.50. For the second month, that is 3,000 times the quantity of 1 plus 0.0075 raised to the power of 2, and that gives us 3,045.17. For the fourth month, that is 3,000 times the quantity of 1 plus 0.0075 raised to the power of 3, and that gives us 3,068.01. Then for the fifth month, that is 3,000 times the quantity of 1 plus 0.0075 raised to the power of 4, and that gives us 3091.02. Then lastly, for the 6th month, that is 3000 times the quantity of 1 plus 0.075 raised to the power of 5, and that gives us 3114.20. Sum all the compounded amount per month, then that gives us 18,340.89. Thus, we can say that the amount of this annuity or the future value of the annuity after 6 months is 18,340.89. Based from the computation earlier, we can say that there is a formula for the future value of an annuity. So, the future value of an ordinary annuity with regular payment R at nominal interest rate I compounded M times a year after T years is given by capital letter F is equal to capital letter R times the quantity of the quantity 1 plus I over M raised to the power of M times T minus 1 all over I over M, or that is equal to F is equals to R times the quantity of the quantity 1 plus J raised to the power of N minus 1 over J, where J is equal to I over M and N is equal to M times T. Since we already know the formula for the future value of an annuity, now let's try to apply this formula from our previous example. The given R is equals to 3000, I is equals to 0.09, M is equals to 12, T is equals to 6 over 12 or 1/2. So that gives us J is equals to 0.0075 and N is equals to 6. So we have the formula F is equals to R times the quantity of 1 plus J raised to the power of N minus 1 over J. Substituting the givens, that gives us F is equal to 18,340.89. The answer, if we use this formula and we use the other process, is just the same. Therefore, the amount of the future value of Mrs. Manda's savings after 6 months is 18,340.89. Thus, using different kind of process in finding the future value of an ordinary annuity comes up with the same answer. Take note always that in solving problems like this, it is very important to maintain the numbers in decimal. Rounding up must be done only at the final answer. So now let's have another example. Example number 2. Suppose Mrs. Manda would like to deposit 3,000 every month in a fund that gives 9% compounded monthly. How much is the amount of the present value of her savings after 6 months? This problem is look like similar to example number 1. However, the unknown of this problem is the present value of her savings. Therefore, we will be needed the formula for the present value. The formula for the present value is equal to capital letter P is equal to capital letter R times the quantity of 1 minus the quantity of 1 plus I over M raised to the power of negative M times T over I over M, or that is equal to P is equal to R times the quantity of 1 minus the quantity of 1 plus J raised to the power of negative M and negative N over J. Since we already know the formula for the present value, then we will find the givens of the problem. We have R is equals to 3,000, I is equals to 9% or that is equal to 0.09. M is equals to 12. P is equals to 6 over 12 or that is 1 half. Computing for J, that is I over M and that is equal to 0.0075. And our N is equal to 6. Substituting the given to the formula, we have P is equal to 3,000 times the quantity of 1 minus the quantity of 1 plus 0.0075 raised to the power of negative 6 all over 0.0075. That is 3,000 times the quantity of 1 minus the quantity of 1.0075 raised to the power of 6 all over 0.0075 gives us 3,000 times the quantity of 1 minus 0.9561580178 all over 0.0075. That is 3,000 times 0.0438 4198 223 all over 0.0075. And that gives us 3,000 times 5.84 55 97 63 and P is equal to 17,536.79. Therefore, we can say that the amount of the present value of Mrs. Manda's savings after 6 months is 17,536.79. Do you want more? Then, try this problem. A certain fund currently has 100,000 and invested at 3% interest compounded annually. How much withdrawal can be made at the end of each year so that the fund will have zero balance at the end of 12 years? Since withdrawal are made every end of the year, then this is an ordinary annuity. Events are periodic payment, that is 100,000. Term is equal to 12 years. Interest rate per annum is 0.03. Number of conversion per year is 1 since it is annuity. Interest rate per period, so that is J is equals to I over M and that is 0.03 divided by 1 and that is equal to 0.03. So solve the problem. 1 minute and 30 seconds. Remember that those formula presented are not only used for calculating or future value of the problem, but working out the formula, we can also use it in finding other amounts of problem. For example, if the unknown is the regular payment, then it is also time is up. If your answer is 10,046.21, then that is correct. Do you have any questions? Feel free to ask that one. We will enter explain that later on. During our break, answer these questions. Number 1. How will you differentiate simple annuity and general annuity? Again, how will you differentiate simple annuity and general annuity? Number 2. What is an ordinary annuity? Number 2. What is an ordinary annuity? Number 3. What is the formula in finding the future value of an ordinary annuity? Identify each variable represent. Number 3. What is the formula in finding the future value of an ordinary annuity? Identify each variable represent. Number 4. What is the formula in finding the present value of an ordinary annuity? Identify each variable represent. Number 4. What is the formula in finding the present value of an ordinary annuity? Identify each variable represent. But for now, let's have a short break. When we come back, let's have the summary of our presentation. So don't go away. I will be right back after a few minutes.
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
And we are back. How are you, student? Are you still fine? Well, that's great. Now, let's summarize the lesson through checking your answer from the question posted before our break. For question number 1, how will you differentiate simple annuity and general annuity? Well, simple annuity is an annuity where the payment interval is the same as the interest period, while general annuity is an annuity where the payment interval is not the same as the interest period. The computation that we have is an example of simple annuity. General annuity, however, is discussed on the next lesson. Most example of annuity in real life follows simple annuity. What is an ordinary annuity? Ordinary annuity is another classification of annuity wherein the payments are made at the end of each payment interval. What is the formula in finding the future value of an ordinary annuity? Identify each variable represent. So the formula of the future value of annuity is given by F is equal to R times the quantity of 1 plus I over M raised to the power of M times T minus 1 all over I over M. Or in shorter way, that is F is equal to R times the quantity of 1 plus J raised to the power of N minus 1 over J, where J is equal to I over M, N is equal to M times T, and R is the regular payment, F is the future value of an annuity, J is the interest rate per period, and N is the number of payment. For number 4, what is the formula in finding the present value of an ordinary annuity? Identify each variable represent. So the formula for present value is given by P is equal to R times the quantity of 1 minus the quantity of 1 plus I over M raised to the power of negative M T over I over M. Or that is, in shorter way, is equal to P is equal to R times the quantity of 1 minus the quantity of 1 plus J raised to the power of negative N over J, where J is also equal to I over M and N is equals to MT. And R is the regular payment, P is the present value of an annuity, J is the interest rate per period, and N is the number of payments. Take note that the periodic or regular payment R can be derived from both formula of future and present value depending upon the given of the problem. So try to answer this one. Answer as indicated. Write your answer in a sheet of paper. Find the future value of an ordinary annuity with a regular payment of 1,000 at 5% compounded quarterly for 3 years. Number 2. Find the present value of an annuity with regular quarterly of payment worth 1,000 at 3% annual interest rate compounded quarterly at the end of 4 years. Ask that one together with your module on the next retrieval. That would be all for this afternoon. Have a blessed day and keep safe, everyone.